My name is Eric Scott, and this is my submission for Lab 6. So here's my circuit. I run 5 volts and ground from the Arduino into the breadboard, and then I run those 5 volts through the potentiometer, and I take the output voltage from that potentiometer in this white wire into the analog input pin A0, and then the rest of these wires, this orange one, is the output from digital pin 2 that runs to my servo motor, and then these two are the 5 volts in the ground that also run to the servo motor. And as you can see, when I turn the potentiometer all the way in one direction, I get the negative 90 degrees, and if I turn it all the way in the other direction, I get positive 90 degrees for a full 180 degrees of motion. So this is my Arduino code. I declare an integer Vn that's going to hold the voltage from the potentiometer, and I establish this period of 20,000, and that's the 20,000 microsecond period that we want for the PWM signal. And then I declare a time on and a time off float, and those are going to be used for the PWM signal. I set the baud rate, and then I declare the digital output pin 2 is going to be an output pin. In this loop function, I read in the voltage from the analog input pin A0 into Vn, and that's the voltage across the potentiometer. And then I map that, so that voltage can go from 0 to 1023, and I map that to a range of 500 to 2400. And those numbers I came up with experimentally to see what the correct control time periods would be. And I save that number into the time on float, and then I subtract that from the total period to get the time off. And using the same ratio, I find what the angle should be with respect to the negative 90 degrees that it would start at. I print the time that the PWM signal would be on and what the expected angle should be. And then I make the PWM signal by writing the digital output pin 2 to high for as long as time on says to, and then write it low for as long as time off says to.